And I'll call on Andy Beaton to present the sky this month.
Hi, I'm Andy Beaton. I'm here to talk about the sky this month for the next month from here to the next recreational meeting. We've got the usual things I like to talk about, the big picture of what's up in the sky, planetary highlights, lunar highlights. I've thrown in some nearby galaxies as something extra fun to look at. Comets and meteors. I like variable stars. Blake likes double stars. And whatever else is going on in the sky. So starting with the big picture, this is the sky more or less tonight, not far off this time. We haven't got anything really spectacular to look at here. We've got our usual fall constellations. Way down at the end there, we've got some planets. Saturn is still peeking over the horizon just a little bit. Neptune and Uranus up there. All the usual, there's the big square of Pegasus and all the deep sky stuff around there. If we head out in the sky in a month, late in the morning, this is what the sky is going to look like the morning before the next meeting. We've got Mars showing up just on the eastern horizon. Whoop, that's not what I wanted to do. Mars down there. Other than that, not much planetary action to look at. But we've got all the spring constellations already coming up if you're waking up early or staying up very late. The comment has already been made that what I should actually show you is a big blank screen and say you're going to be looking at clouds for the next month, but I'd like to be optimistic. So it's standard time. Don't tell my wife, but I'm actually happy about it. I like it when it gets dark early because we get extra observing time in. Tonight, twilight ends around 6:15. Starts again at 5:12 in the morning, and this is accurate because I didn't have to do any conversion to daylight savings time. By the end of this month, twilight will be ending at 5 after 6, and starting again at 5:42 in the morning. So we've got great big long nights, and not only that, but we've got early nights, so you can get out and start observing right after dinner or even before dinner. You know, get some variable stars observed before you go in for the hockey game, and you know, take advantage of the fact that you know, the darkness is here and we're stuck with it. So what's coming up? The new moon's on the 26th. Everybody is going to care about that. Assuming it's clear, we'll get our best deep sky observing then. Moon is at apogee on December 5th and perigee on November 23rd. If you have a camera and you're interested in performing the experiment, take a picture of the moon on each of those dates and put the two pictures side by side and compare the size and get an idea of just how elliptical the moon's orbit is. It's a nice simple experiment that anybody can do, and if you've got kids, it's a good experiment for them too. November 18th, we have the Leonid meteors coming along. They'll be going on for a couple days before and after, but the 18th will be the peak. On November 28th, the Moon and Jupiter are going to pass very close together, followed by the Moon and Saturn on the 29th. On both of these occasions, it's going to be quite low to the horizon. I don't think you're going to get any super amazing observing done, but they'll be nice attractive pairs for pictures or for dragging your friends out to take a look at the moon and some planets. We have the moon coming up first quarter on December 4th. This is a cool month because there is no full moon between now and the next meeting. The next full moon won't happen until the night after the meeting on the 11th, so enjoy this. This is going to be the greatest dark sky month of your entire life. Last quarter, November 19th, new moon on the 26th. The lunar X is on December 4th, and that's at 1:44 in the morning. For those who don't know, the lunar X is a pair of craters situated in such a way that when the light's coming from a certain angle, it looks like there's an X on the moon. It's kind of cool. We have an occultation of ZC 976 on November 16th by the moon. There are actually a few occultations of stars going on by the moon in this month. I've just put this one into the notes, mostly to draw your attention to the fact that your Observer's Handbook has all kinds of these listed in it. You can dig in there and find cool occultations. It's very interesting to see a star disappear or reappear on the dark limb of the moon. And if you're extra precise and feel like getting involved, there's actual useful scientific data that can be gathered here. Professional scientists care very much for minor variations in the orbit of the moon, and this is one of the ways they get tracked. So if you feel like doing some science, this is your big chance. So planets. Mercury is going to be up in the morning. It's actually one of the best opportunities for the next few months to see Mercury. On the 28th, it'll be at its greatest elongation, which means it's going to be way up in the sky by Mercury standards, which is not very much, but if you haven't seen it, and very many people haven't, it's a good time to go out and give it a try, especially if you have a good eastern horizon. Venus is very low on the western horizon after sunset. It's not appearing very well this month. Mars is going to be appearing in the morning sky, but it's on the opposite side of the sun from us, so it's going to be very small. You're not going to see a lot of detail. You might see the red color, but it's not going to be an optimal time to go looking for it. The big planets. Jupiter is sinking into the western horizon at sunset, and Saturn is following it closely behind. They are, like they've been all year, at a low declination, so if you are out observing, you're not going to be able to see an awful lot of detail. But there's always interesting stuff to see. You'll see the stripes on Jupiter, you'll see the rings, you'll see the moons. I wouldn't go out observing them to do any professional quality observing, but if you've got friends and family who've never seen either of the big planets, it's always a good idea to take them out and impress them. They'll still be worth seeing for that. The ice giants are probably our best planets to look at for this next month. They're both way up in the evening sky. Uranus is in theory visible to the naked eye. I've never actually seen it naked eye, but the numbers are there. Moons of both planets are interesting targets. I mean, the problem is neither of the planets are very interesting in themselves to look at. We don't get to see any weather patterns or stripes or belts or anything on them with any equipment we have here. But the moons are worth tracking, especially Uranus, if you can manage, because Uranus is face on to us instead of edge on, so you'll get to see all the moons at once, in theory, all the ones that are visible to us. But if you've got non-astronomers who are looking for exciting things to see, get them out early to see Jupiter and Saturn, because to be honest, these guys are kind of boring to look at. The minor planets, I thought I fixed that. That should be Eris, not Ellis. Pluto's in Sagittarius. It's pretty much hopeless. There are too many stars there. It's too close to twilight. It exists. If you happen to get a picture around then, you might be able to pick it up. Ceres is pretty close to Jupiter, but it's not going to be bright enough to really be noticeable. It's kind of lost its charm for the next few months. Eris is in Ceres, 18th magnitude minor planet. I'm sure there's somebody in here who has seen an object that dim. And actually, I am curious, and I'll check on the YouTube comments in a few days to see if anyone else has chimed in. But what is the dimmest object anyone here has actually seen or imaged? If anybody wants to shout out, 14th magnitude is about the dimmest I've seen. Anybody? I know someone's seen less than that.
I've tagged quasars.
How dim do you know?
15, 16.
15, 16?
Visual.
Okay.
Wow.
Anybody seen anything dimmer than that, or seen something dimmer than that in an image?
Most of the dim objects are audible.
Oh, okay. I didn't hear that. Anyway, I would be curious about what people have or haven't seen. I mean, I've brought up Eris here at 18th magnitude on the assumption that somebody somewhere in the Toronto Centre has facilities to see something or image something that dim. And I'd be curious to know if it's true or whether I'm actually just wasting my time. This afternoon, after I submitted this, I discovered that there is yet another minor planet in our range, the asteroid Hygeia. Currently not too far away from the Pleiades. It's about 10th magnitude in Taurus, and there's evidence to suggest that it is in fact not just an asteroid, but meets all the criteria to be a minor planet as well. And that one's going to be a nice easy one to find, at least as easy as Ceres. So keep an eye on that. Check your home planetariums and see if you can find it. I like to throw in a bit of deep sky stuff just to give people an idea of what they can be looking for. Usually the beginners find more use from this, but I always like to throw some extra details in for the experienced people. I'm looking at nearby galaxies this month. M31, the Andromeda galaxy, obviously, it's almost too obvious. Triangulum I thought was the more interesting one to dig into this month. M31, it's also got 14 satellite galaxies, so if you're interested in racking up a score of interesting targets, two of them, M32 and M110, are pretty bright, and if you've done your Messier list, you've seen them, but the other 12 are probably more challenging or interesting targets. Both galaxies have tons of globular clusters around them. I've seen one globular cluster around M31. It was about 13th magnitude, but with a slightly larger telescope than my 8-inch, you should be able to see plenty more. There was a Sky and Telescope out a few years ago that actually provided a map for finding the globular clusters around M31, and I'm certain now that we have modern planetarium software, it should be a much easier thing to track down. M81 and M82, also pretty close, not conveniently placed in the evening, but if you wait till later in the morning, Ursa Major should be rising further up in the sky, and you should get a better look at them. So M33, the Triangulum galaxy, large and brightish by galaxy standards. You can actually see it naked eye in sufficiently dark skies. I've seen it in about 200 miles from Toronto. That's far enough away to be able to actually see without the city glow ruining everything. It does have things visible within it. You can see star clusters and hydrogen clouds in a moderate-sized telescope. NGC 588, which is a hydrogen region, is 13.5 magnitude. That's within reach of a modest telescope. And there's a picture, and yeah, there's that big H2 region, and up here we see some huge star formation regions that should be visible with a reasonable telescope as well. It doesn't have a very big core, which kind of indicates it doesn't have a very big supermassive black hole at its center. But, an interesting target nonetheless. Unfortunately, the nature of galaxies is if you're observing in the city, you're going to have a tough time with it. So this is really something where you want to get as far away from the city lights as possible. So we have some comets and meteors coming up. The Leonids are peaking on the 18th. Those are the big ones. I think if it's clear, we'll all be out in our backyard seeing what we can see. After our next meeting on December 14th, the Geminids will be peaking, but we may see some early ones. So if you're out observing, I wouldn't go looking specifically for Geminids before the next meeting, but if you're out, you may see them just being there and seeing what's coming along. We have a couple lesser meteor showers, meteor dribbles. The South and North Taurids, both long-term meteor showers. They're running for months. You're only getting 5 or 10 meteors an hour out of them, but there's a high proportion of fireballs. So if you happen to be out observing and you see a fireball, see if you can trace the radiant back to Taurus and identify it as one of those. We have some comets, not very exciting ones. 10th magnitude is the best we've got right now. These are all the comets visible in the northern hemisphere brighter than 12th magnitude. So it's not a great collection. I don't think you'll be seeing comet tails or anything out of them, but they're there, and if you like looking at comets, and who doesn't, then you've got targets to look for. We can't go a month without a variable star. Z Andromadae is the one I've picked this time, and it's interesting for a number of reasons. It's the prototype for the entire class of variable stars. It goes from 7.7 to 11.3 magnitude, so you can see it when it's at its brightest with a pair of binoculars. Any telescope should be able to get good observations of its brightness. It's an interesting one. It's one of those stars where you get a white dwarf and a red giant orbiting around each other. And the white dwarf is pulling material off the red giant, which forms an accretion disk around the white dwarf that periodically ignites. Now this one's kind of cool because it has some extra twists in there. The accretion disk is warped, and the two stars are eclipsing each other from our point of view, so you get all kinds of weird brightness effects. Now this is a good star for human beings to observe. There's an awful lot of automated telescope programs that are doing the variable star data collection, but they tend to get images every 2 to 3 days over the entire sky. Cataclysmic variables like Z Andromadae, they tend to go a lot faster. They tend to go into outburst over the space of a couple hours. So the way they get caught is we get astronomers like ourselves around the world checking up on it whenever we can. With enough people, whenever it goes into outburst, someone is going to catch it, report it to the database immediately, and the professional astronomers who care about this star or its type will immediately be warned that there's data ready to be collected. So this is another opportunity for science for you and I. One of the reasons I love doing variable stars. For double stars, I've just gone for cheap and flashy this time. Gamma Andromedae, it's right overhead in the evening, and this is one of those Albireo type stars where you get two bright companions with obviously different colors, and they're pretty far separated, so any telescope should be able to split them apart, and you'll be able to see the contrast between the two. This is one the handbook gave 3 exclamation marks, And I'm actually going to recommend that you take a look at that section of the handbook. It lists a whole bunch of double stars with different colors, and this is one of the best of them. So what's coming up in spaceflight? We've got a couple missions carrying supplies to the ISS. Soyuz Progress, followed by a Falcon 9 Dragon. Keep an eye on the Falcon, see if it's going to be one of the landing missions or whether it's just going to crash into the sea when they're finished with the booster. A controversial one here, Falcon 9 launching 60 more Starlink satellites. Some people are really pleased that phone or internet service will be provided all over the world. Some people are annoyed that Elon Musk is going to be putting up more Starlink satellites than there are visible stars. So it's happening anyway. You can at least be aware of that. Hayabusa 2 is returning to Earth with samples from the asteroid it was landing on. And from now until November 20th, from November 20th until the next meeting, the ISS is going to be passing in the early evening. And as always, heavensabove.com will have the time for your own personal location. And because it's going to be cloudy, I've dug up some projects for citizen scientists on zooniverse.org. This is one of those things where they've asked the public to help in analyzing the vast quantities of data they have out there in the electronic world. One project is taking images from the Hubble Space Telescope and searching for asteroids as yet undiscovered, especially ones that are going to be approaching the Earth. This is something that's very valuable for the future of the human race. Another project, searching for a clumpy structure in galaxies. It seems that the structure of galaxies, in particular clumps of stars, varies between older and newer galaxies, and they want your help in gathering the data to do that. And there's another project which is near and dear to my heart, identifying variable stars in the center of the galaxy. They've got a whole bunch of images in the infrared of stars around the center of the galaxy, stuff that has never been seen before, and they've noticed that a lot of them are varying, and they would like your help in measuring the variability, finding the variable stars, and gathering data for the scientists to work with. And that's what we have for this month. And are there any questions?
Any questions?
Ron.
The Lunar X on December 4th at 1:44 a.m. How many hours before and after do you kind of have to look at it?
I think it's about half hour each way.
And
more than that? Okay.
More than half an hour? Okay. And does it say you were in South America? Could you see it the same?
Yes.
Okay.
Yes. The moon will look the same to us no matter where we are on the Earth. It's not something that's going to rely on perspective.
I was wondering if the shadows might be different from that perspective or something.
No, it'll be
Okay.
the same.
Okay. Thank you.
Not so much a question. I heard somebody say that there's a moment when Jupiter, that we can't see on the other side of the Earth, has all four moons either behind Jupiter or over the front. So I don't know whether it's past or coming soon, but it would be neat to see or not see.
Okay, yeah, that's probably worth checking into your observer's handbook and see if it says anything about four occultations or something like that.
To answer Ron's question, that was last Saturday.
Okay. The good news is it didn't destroy the Earth.
I looked up my life list notes. So visual, I've seen magnitude 16.1. Those
Okay.
are quasars.
Excellent.
And that is with Ian Wheelban's big 20-inch Dobsonian.
Okay.
Photographically, using the Burt Gaffney Observatory in Halifax that anybody can use for free, I've imaged down to magnitude 19.2.
19.2, that's a good round number, yeah. Okay, cool. Anybody else want to try and beat that? All right, thank you very much.